Dear students, today we are going to discuss group number 16 of P block elements. Group 16 is also known by the name of oxygen family. You know this by the previous knowledge of +1 class. And the members of oxygen family are oxygen, first member sulfur, and then selenium, and then tellurium, and last element polonium. Polonium is a radioactive element, therefore he is discussed not here. And now, what's about their general electronic configuration? They have general electronic configuration of Ns2, Np4. They have 6 electrons in their valence shell. Now, second property is their atomic size. Oxygen is exceptionally very small. Their atomic size increases on moving down the group. Sulfur is bigger than oxygen, selenium is bigger than oxygen and sulfur, tellurium is bigger, all of these three, and polonium is biggest element. These group 16 element, we have here oxygen and sulfur. Therefore, the more oxides occur as sulfide and oxide. Therefore, these all elements are also known as chalcogens. Chalcogens, because they are ore producing elements, they are known as chalcogens. Students, today in this slide we are going to discuss three properties of group 16 element. The first is ionization energy. Ionization energy, by the knowledge of +1 class, we know that it is inversely proportional to size, atomic size of any element. Inversely proportional to size. As we move down the group, the size increases, therefore ionization energy. On moving down the group, it decreases. Is oxygen size, size of sulfur, size of selenium, size of tellurium. We know that size increasing down the group, therefore ionization energy decreasing. But on moving left to right from group 15 to group 16, group 15 to group 16, there is an exception here. On moving left to right, we know the size is decreasing. Group 15 have larger size, 16 have smaller size. Based on this, the ionization energy should increase, group 15 should less, and group 16 should have more ionization energy. But it is not so. The ionization energy of group 15 is higher than group 16. The answer is hidden in electronic configuration. The outer electronic configuration of group 15 is Ns2 and Np3. Ns2 and Np3. And group 16 is Ns2, as already we have understood this, Np4. These are the electronic configurations of outer electronic. Here group 15, we have seen here that it is half filled, therefore it's extra stable and it's very difficult to remove the electron from here. Therefore ionization energy of group 15 is higher than group 16. The second property is that is, the first, this was the third property, and we are going to discuss now fourth is electron gain enthalpy or electron affinity, known by the name electron gain enthalpy. Again it is inversely proportional to size. It is also inversely proportional to atomic size of any element. inversely proportional to size. Down the group, size increases or electron affinity should decrease. But there is one exception here. The electron affinity or electron gain enthalpy of oxygen is lesser than sulfur. Now, why it is happening so? Because the size of oxygen is very compact size of oxygen. The electronic repulsion becomes more after adding an electron. And the release energy is very less. Therefore, electron gain enthalpy of oxygen is lesser than sulfur. The fifth property we are going to discuss here, that is electronegativity. Also follow the same trend. Electronegativity is also inversely proportional to size. There is no exception here. Electronegativity here. Electronegativity inversely proportional, again size no exception in this case. Down the group, size increases, electronegativity decreases. Left to right, size decreases, electronegativity increases. And today we are going to discuss physical and chemical properties of group 16 elements. First of all, some physical properties. First point, all these elements exhibit allotropy. Number two, the melting and boiling point increase with an increase in atomic number down the group. Third one is the large difference between the melting and boiling point of oxygen and sulfur may be explained on the basis of their atomicity. Oxygen exists as a diatomic O2 while sulfur exists as S8 molecule. Why is happening like this? This question will also discuss later on. Question is, oxygen exists as O2 while sulfur exists as S8, or in other words, oxygen is gas and sulfur is solid at room temperature. Why? All the question will have the same answer. We will discuss on the next slides. Chemical properties. Chemical property, here we are mainly discussing the oxidation states, trends in oxidation states. First of all, the oxidation states are totally dependent on their electronic configuration. In the previous slide, we have seen that they have the outer electronic configuration ns2 np4. Therefore, on outermost shell there are 6 electrons, 2 in S and 4 in P. The stability of -2 oxidation state decrease down the group. Polonium hardly shows -2 oxidation state. Since electronegativity of oxygen is very high, it shows only negative oxidation state as -2. Exception is there. When it combined with fluorine, it forms OF2 where the oxidation state is +2 because fluorine is more electronegative than oxygen. Fourth point is other element of group exhibit +2, +4, +6 oxidation states, but +4 and +6 are more common. Point number 5, sulfur, selenium, tellurium usually show +1 oxidation state in their compound with oxygen and +6 with fluorine. Point number 6, the stability of +6 oxidation state decreases down the group and stability of +4 oxidation state increase due to inert pair effect. We know this, what is inert pair effect. In group 15, we studies this effect. Point number 7 is very important. Bonding in +1 and +6 oxidation state Today we are going to discuss the anomalous behavior of oxygen ANALOUS. Anomalous behavior of oxygen. anomalous behavior of oxygen we are going to discuss here. What are the causes? It is due to mainly three reasons: small size, high electronegativity, and absence of d orbital in valence shell. As we know, oxygen has the electronic configuration 1s2, 2s2, and 2p4. Outermost shell is second. There is no 2d here. Absence of d orbital. The main three reasons are for anomalous behavior of oxygen. For small size is small, electronegativity will be automatically high, and the main thing is that the oxygen is having outermost shell is second, and second shell don't have d orbitals, d subshell. Therefore, its covalency is maximized up to 4. It can't increase its covalency beyond 4. Now, next property of these element is formation, a reaction with oxygen. Chemical property, we are going to start now with the reaction with oxygen. Reaction with oxygen, O2, or either what we can say formation of oxides. They form two types of oxide. One is EO2 and other type of oxides are EO3. E is the any element of group 16. As usual, we are studying the group 16. The all thing is discussed about group 16. For example, if I take E is O, then it will be O3, and E I take S, then it will be SO2, and if I take Se, then it will be SeO2, and similarly if I take tellurium, then it will be TeO2. All these oxides are forming TeO2. These are the oxides of group 16 members. All these have here +4 oxidation state. All these oxides having a central atom have oxidation state of +4. We know that they have only two types of oxidation state, +4 and +6. +4 and +6. The stability of +6 oxidation state decreases on moving down the group. It decreases +6. And stability of +4 oxidation state as we move down the group increases. We have studied this previous slide, in previous slide. Okay, now on the top, the element, it is very difficult it is very easy to lose 2 electron and change from 4 to 6, because 6 oxidation is very stable at the top. Therefore, the which can give the electron, the element, the compound which can give the electrons, it is a reducing agent. Therefore, tendency to give 2 electron and changing into +6 decreases on moving down the group, because downward the stability of +6 oxidation state is decreasing due to inert pair effect. We know this effect, that is inert pair effect. It is inert pair effect. Inert pair effect. And as we downward, the reducing nature of these oxides decreases. And other type of oxide here formed, these are EO3 type. For example, SO3, we know sulfur trioxide. These are also oxides of and SeO3. EO3 types are also there, and SeO3, similarly TeO3. These are some oxides of group number 16 which we have discussed here. The main thing is that summarization, that reducing character of oxides decreasing on moving down the group due to inert Dear students, in this slide we will discuss hydrides. We will discuss hydrides of group number 16. Hydrides. Hydrides we are going to discuss in this slide. All the elements form hydrides of type H2E. E is any element of group number 16. For example, we have all the hydrides I am writing. First of all, I am writing first hydride H2O, and then second hydride is H2S, hydrogen sulfide. Third hydride is selenium hydride. Selenium hydride, and third hydride I am writing is tellurium hydride. I am writing all the hydrides. Before discussing their properties, we should have some basic knowledge. As we know, the size of central atom oxygen, sulfur, selenium, and tellurium goes on increasing as we move down the group. Now its oxygen, sulfur, selenium, tellurium, all these elements are written. Now hydrogen form bond with them now. Hydrogen form bond, the center between two, the distance, center of the two is the chemical bond, bond length. Now it's hydrogen and bond length is increasing. Again hydrogen overlapping with the selenium and bond length again increasing. In other words, as we move down the group, the bond length increases. Bond length increases. Bond length increases. Bond length increases. If bond length increases, then bond dissociation energy decreases. Bond dissociation energy decreases down the group due to decrease in bond dissociation energy down the group. Their acidic nature will rise because the tendency to give H positive will become more. Their thermal stability will decrease down the group. Their reducing nature will increase on moving down the group. These three properties, the first one is acidic nature. First one is acidic nature. Acidic nature character. Second one is thermal stability. Stability. Thermal stability. And third one is reducing nature, reducing character. Reducing character. All these three properties are totally dependent on the bond dissociation energy. Acidic nature directly proportional to bond acidic nature. If bond dissociation energy decreases down the group, the acidic nature will increase. Acidic nature inversely proportional to bond dissociation energy. Thermal stability, if bond dissociation energy is strong, is more, the thermal stability is also more. Therefore thermal stability is directly proportional. And reducing character means a tendency to give H. It is inversely proportional. It is also directly proportional. If down the group dissociation energy decreases, and reducing nature increases. Therefore, the reducing nature is inversely proportional to bond dissociation energy. Again, H2O, in case of H2O, due to small size of oxygen, H2O can form hydrogen bond. Therefore, H2O is a liquid due to presence of intermolecular hydrogen bonding, while all the other hydrides are gases. We know H2S is a gas, all other as gases. And boiling point, as long as are concerned, down the group boiling point increases due to increase in size. Increase in size result in increase in van der Waals forces, and that will lead to increase in boiling point. Water have exceptionally high boiling point. Exceptionally high boiling point due to the presence of intermolecular hydrogen bonding, due to presence of this small oxygen atom. And if we see the structure of water and the other hydride, water is like that. H2O, we have studied the structure in +1. It is a structure of water, and two lone pairs are there here, two lone pairs are there. I have made this. And if we move down the group, is the bond pair, this is bond pair, his bond pair, two bond pair, two lone pair. As we move down the group, the repulsion between lone pair, lone pair, bond pair increases. Therefore, bond angle decreases on moving down the group. It is all about the hydrides of group 16.